So what we do for this example is we want to find the chromatic number for each graph. So let's consider the first graph. So I'm going to say this is V1, V2, V3, V4, V5, and V6. So each vertex completely connected to all the vertices. Therefore, this type of graph is called the complete graph. Alright, so and again for the complete graph, one vertices connect to all the vertices in the graph. So when you color the vertices, what you do is that you have to use different colors altogether. So V1 has pink, V2 have red, V3 has orange, V4 have purple, V5 have yellow, and V6 has green. Alright, so the chromatic number of this graph is equal to 6. Now for the second graph, let's say you have this to be V1, V2, V3, V4, V5, and V6. So V1 is adjacent to V2 and V3, V2 adjacent to V4, V3, and V5, V3 is adjacent to V5 and V6, so on and so forth. So I'm going to start out from the top and give a ping for V1, and V5 is not connecting to V1, so I can have ping as well. And now V2 is red, and V2 is not connected to V6, so we have red as well. And V3 should have a different color from V1 and V2, V5 and V6. Now V3 and V4 are not connected to one another, or they are not adjacent to one another, so they can have an orange color as well. So the chromatic number of this graph should be equal to 3. Now for the last graph, so let me name this V1, V2, V3, V4, and V5. So for V1 and V2 are not adjacent to one another, so they should have the same colors. V3, V4, and V5, they are not connecting to one another, or they are not adjacent to one another, so they can have the same colors, but the color should be different from pink. So I use red. So the chromatic number in this case is equal to 2. Sometimes calculating the exact value of chromatic number can be challenging for more complicated graphs on network. There are definitions and theorems that can help you identify the chromatic number a lot easier. To help with identify the chromatic number, I'm going to give you some definition. It's about planar and non-planar graphs, and the theorem is the four-color theorem. And after that, I'm going to move on to an example. Okay, so the definitions of planar and non-planar graph. So a planar graph is a graph that can be drawn on the plane so that none of the edges cross each other. So a planar graph is a graph that can be drawn on a plane so that none of the edges cross each other. So for example, on this graph, this is a planar graph, and this is a non-planar graph. If edges are crossing one another, the graph is non-planar. The issues or the complications between this definition is that when you see a non-planar graph, you can redraw it to get to a planar graph. All right. So from this example we see earlier, this is a non-planar graph, and this is a planar graph, because in this case the edges crosses one another when you draw the graph. In this case a planar graph because the edges are not crossing one another. For this graph, it look like a non-planar graph, but we can actually redraw this to lead to a planar graph. So this is V1, V2, V3, V4, and V5, and if we redraw the graph as follow, so V3, V4, and V5 like this, we're going to see that this is a planar graph. So I can say that for this last graph, this is non-planar, but can be drawn as planar. Now there's a formula for you to check if a non-planar graph can be redrawn as a planar graph, but it's again more complicated as we go. So I'm going to skip that. Just want to use the definitions of the planar and non-planar graph for the following theorem. It's called the four-color theorem. So the theorem say that if the graph G is a planar graph, then the chromatic number is less than or equal to 4. Then the chromatic number less than or equal to 4. Now I'm going to move on to the example and going to see a planar graph, and you can use 4 colors to sufficiently color the graph. So in this example, we want to color the countries that border to one another. So I have a map of European countries here, and you can see there's a lot of colors in the map. But the question is, can you use the list number of colors to color the map? All right, so the focus is only on a few countries here. As you can see on the map here, I use a vertex to represent a country and an edge to represent a border. Again, the question is, can you use the least amount of colors to color the country instead of multiple colors here? What I'm going to do now is take out the graph created here and slightly move it so that it helps us visualize the position of the countries in terms of graphs. So this is the graph of the countries that we have. So again, by the look of this particular graph, you can see that all the edges are not crossing one another, and therefore this is identified as a planar graph. So this is a planar graph. And by the four-color theorem, this graph will have the chromatic number of less than or equal to 4. That is, the number of color used in coloring this map will be less than or equal to 4. And when you draw this, you're going to see that we need 4 colors to fully color this particular graph. All right, we're going to start out from Belgium and going down to Vatican City. So Belgium is pink, and the adjacent vertices have to have different colors than Belgium. So you have blue here for France, red for Luxembourg, orange for Germany, and then Poland here. So they are adjacent to Germany, so they need to have a different color. So I go back to pink, and Czech Republic needs to have a different color compared to Germany and Poland. I'm gonna go back to red, and Austria, I'm gonna use blue here. For Liechtenstein, I'm gonna use red. In Switzerland, I'm going to use pink again. Again, we try to follow the idea is that the adjacent vertices have to have different colors. Then we're going to go to Monaco and use pink as well. You technically can use pink, red, or orange at this node. So now let's go to Slovenia. And I'm going to use pink here. In Croatia, you can use blue here as well. Again, I can use blue, I can use orange, I can use red if I want to. And go to Italy. So Italy has to have a different color compared to France, compared to Switzerland, compared to Austria, and compared to Slovenia. And I can use red here. Or I can use red, I can use orange if I want to. For Andorra, I can use orange for now, and I can use red here, and then Portugal, I can use another orange if I want to. So of course there's multiple solutions here, so this can be red, and this can be orange, this can be red again if I want to. Now for Italy, to go to Vatican City should have a different color compared to Italy. I can use orange here, and San Marino, I can use orange here as well. And the number of colors that we use so far are only 4 colors, so the colors are going to be pink, red, orange, and blue. Therefore, the chromatic number is equal to 4. So that's it for me in terms of graph coloring. I'm going to move on to another video where I use Python to help us solve this type of problem in vertex coloring or graph coloring. In that video, you're going to see that I'm going to approach using a algorithm called greedy coloring. And it's not the most optimal coloring technique, but it gives you an idea of how to solve the problem. You will see that in the next video. That's it for me. Please let me know if you have any questions.